Okay, let's do a new problem today. The problem is search in a matrix. Actually, we have given a matrix and a number. Normally, we have to find that the number is present in the matrix or not. So first approach maybe general, like we can use we can use the to for loop to traverse the whole matrix, and if it is there, then we can return one and not zero. So the optimized approach should we in log n or we go often. So what we will do, we will use the binary search. Like we know that in binary search what we do. Let's suppose it is a array. First we will search that uh, the value, is it in this particular area or not. If it is, then we will reduce the length and then check in that. Let's suppose let's suppose the value is in this interval, then we check now in this interval. If we find that the value is in this interval, now we will check again in this interval until we did not find that value. So same approach we will use here. Okay, what we will do, let's suppose we have given this array. First we will check that the value is it in the first row or not. If it is not, then we will check in the next row. Let's suppose the value is in the second row, then we will check that we will reduce the length of that array. Let's suppose we will check that we will check for the 52 in the first row. It will we will it find or not. Let's suppose it is 3, 30, and 38. The value, is it in this index? Not. So we will increase the uh, we will go to the second row. What will be it? 44, 52, and 54. Now we will check it is 52 is in this area, which is less than 54 and greater than 44. Yeah, obviously 52 is it in this. Then we will decrease the length of the columns. Now we will check in this index. Is it 40? Is it in the 44 and 52? Yeah. Then we can return it is present there, or it is present there. So now let's code. So for that we need two pointers. First will be at the initial position, and second will be at the end of the row. And it will be ij is equal to m minus 1, because we have the length of uh, our row is equal to m. Now while I is greater than or equal to 0 and I is less than n, as well as our j should also be greater than 0. If m estimate I comma j is equal to x, then it is present, then we can return 1. Else, if our mat I comma j is greater than x, let's suppose our I is equal in first row and our j is equal to 2 at the end of that row, then what will it? 38. Then our x, what is our x? Our x is equal to 62. Then our matrix, sorry, it will be we will check for it for the less than. Now our 38 is less than 62. Okay, less than 62. It means that our target will not be found in that row, because all the element in that row are less than the 38, and we need the bigger element than 38. So now we will check in the second row, because because all the elements in second row are greater than the first row, because the matrix are also sorted in the column wise. So what will we do? we can I plus plus, else if now if our matrix is greater than if our matrix I comma j is greater than x, then it is absolutely in that row, so we can decrease the column and check. Now can if it does not find anything, then we can return 0. Okay, now this is our last code. Now compile it. What is the error? Error deletion in I. Okay, okay. Give me a minute. Now recompile it. The code is right, don't worry. This is the program. Okay, XO. It's not small, it's capital. Let's submit it. Yeah. Okay. Thank you guys.